2-1 Day 1 Basic Functions and their Graphs. This is our first lesson for analysis of functions. Your learning goal is that you will be able to build functions that model relationships between quantities from existing functions. So let's first talk about what a function is. And a function is a correspondence from a first set called the domain So we are corresponding elements of the domain to a second set called the range. And the importance about this is that each element in the domain corresponds to exactly one element in the range. So not only does it correspond from the domain to the range, but exactly one element from the domain corresponds to exactly one element in the range. And I'll show you what that looks like. So let's say, because you're going to see the relations can be in ordered pairs. They can be a graph. They can be an equation. So let's see how that looks. So as an ordered pair, you're looking at the x values, which are your domain values. And each element in the domain has to have exactly one element in the range. So you see there's only 1, 1, 1, 2, 1, 3, 1, 4. So your domain will be your domain would be 1, 2, 3, and 4. And your range is 6, 8, and 9. So as long as each element in the domain corresponds to one element in the range, it's a function. What that means is no x or no first element can be repeated. So if you have something like this, then this is not a function because you have a 6 that is being paired with a 1 and a 2. So this is not a function. And this one is a function. Now, you can also look at it as an equation. So if you had an equation like x squared plus y equals 4. Now, you can still check if you plug in an x value and always use 0. And as long as you get only one y value, because 0 squared is 0, so y equals 4, that ordered pair is 0, 4. So no matter what you plug in, you will get one y value. You can try another one just to check to see. We can try plugging in 1. And if you plug in 1 into the equation, you'll get 3. And you'll just keep doing it. So this is an example of a function. Now, if you had something like this, and now when we plug in 0, you're going to get y squared equals 4. And if you square root, y could either be plus or minus 2. So that means 0 would go with positive 2 and 0 would go with negative 2. This is not a function. So even if it is an equation, you can still check They're not going to give you ordered pairs or numbers, but you can plug in your own numbers to check. And even if you plugged in 1, or let me use, if you plug in 1, you'll get positive square root of 3, and you'll get negative square root of 3. So if you plug it in and you get more than one value, you know it's not a function. Okay, and then we have function notation, which looks like this, which basically means that x is your input. So you're inputting the x value into a function, and you're getting one y value. So it's read f of x. That means the value of the function at that number x. So if they gave you a function like this, and they ask you to evaluate, for example, f of 2, that means when x is 2, you're going to plug it in and find your y value. So you're basically just substituting in the x value, and you're going to notice that when you work it out, you're going to get 4 plus 6 plus 5, which equals 15. So that means when x is 2, your input is 2, your output will be 15. And then sometimes they'll have you to input an actual expression. So you'll actually plug in the whole expression for x, and which means you may just have to FOIL. So I'm going to FOIL this part and get x squared plus 6x plus 9. And then I have to distribute this. And then I'm just going to combine like terms. So instead of getting an actual number, you get an expression. So when your input is x plus 3, your output will be x squared plus 9x plus 23. And sometimes they may ask you to plug in negative x. So you'll do the same thing. Your input is the opposite of x. And so when you square negative, that becomes positive. That's negative. And so when x is negative x, that is your output. So that is function notation.